Okay, guys. So this is part 5 of our exponents and sets. Okay, so we have example 3 here. Example 3, and then we need to simplify the following. Simplify. This thing, it looks like this: 4 exponent n plus 2 times 9 exponent n minus 1 divide by 72 exponent n times 2 exponent 1 minus n. Okay, so remember, I always advise you that make sure that whenever you work with exponents, make sure that your bases are prime number bases. Okay, so just make sure that your bases are prime numbers. Okay, so you know that 4 is not a prime number, and then how are you gonna make it a prime number? You just go to your calculator, you press 4 equal sign and then shift fact. Okay, then you will notice that it will write 4 for you as 2 exponent 2 into n plus 2. Okay, so it's only going to give you 2 exponent 2. That n plus 2, it has been there all along. Okay, multiply by 3, you do the same. It's going to give you 3 exponent 2, and then that n minus 1, it has been there. Okay, you divide. Sorry about that. Oh, what did I do now? Okay. Okay, that's an equal sign. Okay, then after that, what do we do with 72? So 72, you just press 72 on your calculator. You say equal sign, you say shift, and then you press fact. Okay, so fact, it is a button on your calculator that has this thing sign like that. Okay, so when I say fact, I talk about this. Okay, so check it, it's there on your calculator. Then you will definitely get, for 72, you will get 2 exponent 3 times 3 exponent 2. So you see now our bases are prime numbers, but then you mustn't forget that 2 there, and you write it like this: 2 exponent 1 minus n, this one. Okay, then let's continue. Then now from there, you can see that you have the powers of the same bases multiplying, dividing each other, and then down there on the denominators, they are multiplying each other. Okay, so let us quickly simplify this. So you can simply say that 2 exponent 2 times n, it is 2n. 2 times 4, it is 2 times 2, it is plus 4. Okay, times 3 exponent 2n minus 2. I'm just simplifying that. And then here, n minus 1. This is n minus 1. How did I end up there? 1 minus n. I'm sorry, 1 minus n. Okay, then here, group these two, because of you will be multiplying the powers of the same base. This base and that base are the same. Okay, so you have the right to write it as 2 exponent 3 minus 1 minus n, like that, times 3 squared. Okay, then this is equals to, and now you can say that you are dividing the powers of the same base, you see here. So if you divide the powers of the same base, take one base to represent those bases, and then after that subtract the exponents, meaning that you subtract the exponent of the denominator from the numerator. Okay, so the one for numerator comes first: 2n plus 4 minus, right, we should have simplified this one, but then if we were simplify that one, it was going to be 3 minus 1 plus n, like that. Okay, multiply by. So now you are dividing the parts of the same base. 3 and 3 are the same bases. Okay, then you know what to do when you divide the parts of the same base. You take one base and then you subtract the exponent of the denominator from the numerator. Okay, minus 2, simply like that. Then now we can simply say that 2n plus 4 minus 3 plus 1 minus n times 3 exponent 2n minus 2, they will give you minus 4. I hope we are together, guys. Then your answer here, it is going to be, notice that these are numbers, and then we have 2n minus that n, 2n minus n, it is n, right? Plus 4 minus 3, it will give you 1 plus 1, okay? Plus 4 minus 3, it gives you 1, and then plus 1, it gives you 2. So it's gonna be plus 2, okay? And then times 3 exponent 2n minus 4, simply like that. And then I don't know where did I go wrong, but then it seems like there's something wrong that I have done, or maybe I didn't copy it right, I don't know. Okay, yeah, so that's it, guys. Okay, actually I forgot n here. Okay, guys, I forgot n. I just treated it as a 72. Okay, just for the sake of time, let us do this. We remove that n there. Okay, so all this thing, it had no n, and then our answer ends up being that. Okay, so and then now let us take another example there. Okay, guys, we have another problem here. It says that show that it wants us to prove. Okay, show that 2 exponent x plus 1 plus 3 times 2 exponent x, it is equals to 5 times 2 exponent x. Okay, so it's a matter of proving. We need to prove this thing. Okay, so let us pay attention. So we have 2 exponent x plus 1, okay, plus 3 times 2 exponent x. Okay, so notice that this one, 2 exponent x plus 1, it is the same as 2 exponent x times 2. Okay, remember this, when you apply this, you are going to say that when you multiply the powers of the same base, you add the exponent. So you are just going to take one base and then you say x plus 1. So now I am going to write this thing like this. Okay, so 2 exponent x times 2, okay, plus 3 times 2 exponent x. Okay, so why am I writing it like this, guys? Here we have an equal sign, guys. Sorry about that. I don't know why do I keep on forgetting the equal sign. Okay, so why was I writing it like that? It's because of I wanted to have a common factor. Okay, so if you check on this line here, we have 2 exponent x as a common factor, meaning that it appears on this term and then it also appears on that term. Okay, so take it out as a common factor. Okay, and then once you take it out as a common factor, here you will remain with 2, plus here you will remain with 3. Okay, then after that you are simply going to say that 2 exponent x, and then that part is going to give you 5. Okay, what were we asked to prove? Okay, we were asked to prove that it is the same as 5 times 2 exponent x. Remember, multiplication, it is commutative. What do I mean by commutative? I mean that the order doesn't matter when you multiply. You can start with any. Okay, I can start with 5, write 5 first, and then write 2 exponent x after. Okay, and then let's check B. B, it says the following. As a single power expression. Okay, so we want to express 9 exponent x minus 1 plus 3 exponent 2x. We want to express this thing as a single power expression. Okay, guys, so how are we going to do that? So the first thing, let us write 9 with a prime base. Okay, so it's going to be 3 squared. 9, it is the same as 3 squared. And then don't forget that x minus 1 plus 3, it is a prime number on its own, so we just leave it the way it is, 2x. Okay, so and then from there we simply going to say that we are simplifying. So 2 times x, it is 2x. 2 times minus 1, it is minus 2 plus 3 exponent 2x. I am going to do the same thing as I did earlier on. Okay, so I know that 3 exponent 2x minus 2, it is the same as what? It is the same as 3 exponent 2x times 3 exponent minus 2. Okay, why am I doing this, guys? I want to have a common factor on these terms. Okay, so I know this thing, it is the same as that one. Okay, so now we are going to write this as 3 exponent 2x times 3 exponent minus 2 plus 3 exponent 2x. Okay, and what are we going to do? We are simply going to say that we have a common factor on this term and on that one. Our common factor, the thing that appears here and also appears there, it is 3 exponent 2x. You open, and then what are you left with there? You are left with 3 exponent minus 2. And then what are you left with here? So we are left with 1. So if you say this multiply by that, will take you back there. Hope we are together. And after that, 3 exponent 2x, open bracket, 3 exponent minus 2 plus 1. Our answer is going to be 3 exponent 2x. And what about this one? It is going to be 1 over 3 squared plus 1. Okay, and then that thing there, it is the same as 1 over 9 plus 1. Okay, so what is our answer? 3 exponent 2x. 1 over 9 plus 1, it's how much, guys? It is 10 over 9. Then you have managed to write it as a single power expression. Okay, let's do C. So on C, we are being asked to simplify. Okay, can we simplify, guys? Let us simplify this thing. what do we have? We have 3 exponent x plus 2 minus 3 exponent x, all divided by 3 exponent x plus 1 minus 3 exponent x minus 2. Okay, so our equal sign there. So here, guys, you see we are going to check our bases. Our bases are in prime numbers. Can you guys see that? So we are not gonna worry about changing them to make them a prime numbers. Okay, so what we can do, we can apply that rule of ours. So this 3x plus 2, we know that it is from 3x and 3 exponent 2, okay, minus 3 exponent x. You know the reason why we are doing that, right, guys? It is because of we want to have a common factor. This one you can separate it and write it as 3 exponent x times 3 exponent 1. Even if you don't write it, it's still important. Minus this one, you can write it as 3 exponent x times 3 exponent minus 2. Okay, then it will definitely be that here you have a common factor because of it appears here and then it also appears there. It's 3x common factor, and then you will remain with 3 squared minus 1, right? And then from there you are going to have another 3x as a common factor here, and then you are going to remain with 3 minus 3 exponent minus 2, right? Yes. And then now you can simply see that this and that are the same, therefore they will cancel each other. Okay, then 3 squared minus 9, it is the same as 9 minus 8, 9 minus 1, I'm sorry. And then that part is going to be 3 minus 1 over 3 squared, and 9 minus 1, it is 8, and then there we are going to have 3 minus 1 over 9. Okay, and you can simply press your calculator and then give us the answer for that. And then our answer, it is supposed to be 36 over 13. Okay, let us simplify the last one quickly, and then I will give you exercise, guys. Okay, so let us simplify this one quickly, and then you will definitely get an exercise. So we are simplifying this. We have 3 exponent 2x minus 1, all divided by 3 exponent x plus 1. Okay, so what's really gonna happen here? Which rule or which law are we going to apply? Okay, so this one is a bit tricky, guys. I'm gonna try to slow down time, ne? But then because of it's very tricky. So remember that rule that we had there when we said a exponent m times n. We said it is the same as a exponent mn. Okay, so this is exactly how we are going to treat 3 exponent 2x. So we are going to say that 3 exponent 2x, it is the same as 3 exponent 2 and then x outside there. I don't know if I'm making sense, guys. And then this is the same as 3 exponent x times 2. Why am I saying that, guys? Remember that the multiplication is commutative. Okay, so and then I have a reason why am I doing that. It's because of I want to make it look like this one. I hope you get my point, guys. Okay, So let's continue now. Then this, we are simply going to write it like 3 exponent. I don't know what's wrong here. 3 exponent x times n, or times 2 minus 1. I hope this makes sense, guys. Okay, all divided by 3 exponent x plus 1. Right? So now, remember, guys, the difference of two squares. Remember, difference of two squares, it was something like x squared minus 1. Okay? Or sometimes it will be something like maybe let's say b squared minus 1. This is still a difference of two squares. And then if it's like this, we know that we are going to open two brackets like that, and then the other bracket will have b plus 1, and the other was going to have b minus 1. Okay, so we are going to apply the same thing there. So we are going to say that 3 exponent x, remember there's 2 there, right? So it makes it a difference of two squares, plus 1 and 3 exponent x minus 1, close the bracket. Okay, all divided by 3 exponent x plus 1. Then what do we do from here? We simply, this will go away with it. And then our answer, it will simply be 3 exponent x minus 1. I hope you guys are good. So I just need to give you the work or exercise related to this. Let me just share it now. Here is your homework, guys. So I advise you that just screenshot it, screen grab it, so that you can be able to complete it. Yeah. Remember, guys, we practice and practice and practice, and we become the best. Okay, so we are just not going to be the best if we do not practice. Something that seems to be difficult today, if you can do it 5 times, or if you can try to find extra information about it 5 times, you will see that the more you dig deep, the easier it gets. Okay, so I wish you all the best, guys. Bye bye.